Insertion at the beginning was constant time operation, but insertion at the end is different. Here traversal is unavoidable, and that's where mistakes happen. Let's see how to insert node at the end and build our logic step by step. Here is our initial linked list. And we know that every linked list starts with a head pointer. So we have a head pointer. We want to insert node at the end, which means we want to insert node after this last 30 node. So to insert node at the end, we must reach the last node and the one whose next is null. So as we know that last node's next points to null. So we need to reach this node. How do we do this? Let's use a temporary pointer which points to head to begin with. So we have a temp pointer, and to traverse the linked list, what we do? We move temp to point to next node. Temp equal to temp dash then next. So when we do this, temp will move to next node. So what exactly we need to do? We need to move temp until we reach the last node, which means until temp's next is not equal to null. Let's build our logic step by step now. Let's implement our insert at the end function now. Void insert at end. It accepts head pointer as the input. Struct node star head and data, int data that we want to insert. So to insert at the end, first we need to create a node. So let's create the node by allocating memory. Struct node star, say new node equals to, how do we create? Malloc size of struct node, and we need to typecast this. So typecast it properly. Struct node star. So this will allocate memory. Let's handle null pointer condition. So if new node is null, if malloc fails, it will return null. We will simply return. Now new node is created. Let's initialize it. So new node of data is data and new node of next equals to null. To traverse the linked list, let's use one temp pointer. Struct node star temp, and to begin with it will point to head. How do we traverse? While temp's next is not equal to null, we will traverse. Temp equals to temp dash then next. Why this condition here? Temp's next not equal to null, because we need to reach till this last node, and here we know that temp's next will be null here. So that's where we will break our loop. So at the end of this loop, temp will point to this last node. Temp will point here. So for sure we know that once we come out of this loop, temp is pointing to the last node. So what exactly we need to do? We need to set temp's next to new node. So now temp is pointing here. We have a new node, and then temp's next will point here. And new node is already initialized with data and null. This is our initial implementation, but there is one problem with this code. Can you guess what is the problem? Share your answer in the comment below. We have not handled one special case here. What if list is empty? In that case, head will be null and temp's next will dereference a null pointer. And this is where we will hit a segmentation fault. So we need to handle this condition properly. So how do we handle that? So we have already created a new node. So if list is empty, we need to basically update the head pointer to point to this node. And in the last video, we already did that. So how do we update the head pointer from the function? We need to use double pointer. So if we use this double pointer, then here it will be star head. We need to handle this special case here. So if star head is null, then what we do? We have already created a node. So we need to set our head to point to new node, which means star head equal to new node. And from here we will simply return. I hope this is clear. Let's analyze the complete code. Here we have insert at the end function. As we discussed, it accepts a double pointer now and data value. This malloc statement creates a new node. So we have a new node. Let's initialize with data, and next pointer will point to null because we need to insert at the end. What if list is empty? We need to assign head to point to new node. So if list is empty, we set our head to point to this new node. So head ref will point here. And what if list is not empty? We need to traverse the list until we reach the last node, which means until we reach the node where next is not null. So this loop will handle that case. So we know for sure that once we exit this loop, our temp pointer will point to the last node. And that's where we set temps next to new node. Here is our main function. We start with an empty list. So insert at the head, first call will create a new node and will set the head pointer properly. And then these three calls will create node and add at the end. So once we run this program, our output should be 10, 20, 30, 40. So let's compile and run this code. Let's compile it. Let's run it. So as you can see here, output is 10, 20, 30, 40. Now we have covered all basic insertions. In the next video, we will start deletion, where pointer mistakes become even more dangerous.